this is the circuit of integrator where the source is generating a pulse having lower value of 0 and higher value of 5 volt, and it is integrating a square wave. The output should be given as a triangular wave. And so let's see what is the output. So the square pulse is generating from 0 to 5 volt. It's okay, but the output is not at all as we expect. It is not a triangular wave anymore. So let's check what are the problems with this circuit. So first of all, this resistor, the value that must be 1 mega ohm. So 1 meg I've chosen. Secondly, with this, as you can see that the initial voltage is 0, high voltage is the 5 volt. If I click on there, you can see the 5 volt and 0 volt. The input voltage is oscillating or swing from 0 to 5 volt. And that introduces a DC because the average value of this input pulse is around 2.5 volt, and the DC value may causes problem. So that's why let's change from -1 to 1 volt. In addition, the n cycles means here it is given as 100, so only 100 number of cycles will be simulated. But for our purpose, I don't want to give a particular value, because if I don't give any value, so that cycle will exist or the input will exist forever, and that is my purpose. Now let's check what is my output in this case. So I'm running once again. Now the input is swing from -1 to +1 volt, and this is the output. The output here also is not coming as the triangular wave, but as we can see, the output is gradually taking a form of the triangular wave as time elapses, because these are the transient state. The transient state means the output is trying to settle down to the steady state, but the output has not yet been settled to the steady state. So it is approaching towards the steady state. So during that time, the waveform is changing from some initial state to the final state. So it is taking a form of the triangular wave. So why we can't see? Because as you can see, the time axis is of the order of microsecond. Whereas if you place a mega ohm of the order of resistor, so in order to reach the steady state, you need a time frame of the order of second. During physical simulation in the laboratory, you may not observe this transient state because the microsecond and millisecond order of time, it appears very momentary for us. So that's why we may not see such kind of transient state. What we observe, that is a steady state, because with respect to our time frame, the output reaches the steady state very quickly. But when you are simulating with some simulation software, you may observe the transient state, and in order to observe the steady state, you have to increase the observation time frame. So here I am right clicking on that, and I'm increasing 10 millisecond is a stop time from 8 millisecond, and it is enough. So 0.01 millisecond, because this is the increment should be of the same order as the stop time and the start time will be. And now if I run, look, still you are not getting a steady state, but as you can see, the waveform took the form of the triangular wave. But again, it is decreasing because the steady state should be around 0, because right now this input voltage has no DC part, so therefore the output also should swing around 0. So it is going down to be settled around 0, and from there right now it is at 11.7 volt where the supply is being used 15 volt. Still it is not being reached to the steady state. So for the simulation purpose, if I reduce the value of the resistor as 10k, I think it will be enough for our purpose. Look, as you can see, it reached the steady state, and if I compare the input voltage, you can see the steady state is reached. But one problem still I can find, that is the input is swing from -1 to +1, but the output is not swing around 0, rather it is swing from 0 to -0.4. So it has some negative DC value, we can see, and that is due to the rise time and fall time, because the on time is of the order of 50 microsecond and the period is 100 microsecond. So out of this total period, T rise is taking a time of 1 microsecond, and that is quite large if you compare with this T on and T off. So here, instead of 1 microsecond, put 1 nanosecond, and that will be negligibly small comparing with respect to this T on and T off time. Now if I simulate right now, as you can see, the output is also swing from +2 volt to -2 volt, and we don't have any DC value approximately. If you change the value of the capacitor or the resistor, the amplitude will change. Right clicking over there, if I put that the 0.01 microsecond, you will get an increased magnitude compared with the input voltage. On the other hand, if you put 0.2 rather, you will get a reduced amplitude compared to the previous case. Well, that's all for today.